In electrolysis process, we have seen the anodes are liberating ions. At cathode, the ions are deposited as a metal. That is, the amount of substance liberated or liberated at anode, and these ions are deposited at the cathode. By using Faraday's first law of electrolysis, we can calculate the amount of substance liberated or deposited at the electrodes. First, we see the definition of Faraday's first law of electrolysis. That is, the mass of the substance M liberated at an electrode during electrolysis is directly proportional to the quantity of charge passed through the cell. The amount of the substance liberated at an anode or deposited at an cathode is M. Quantity of charge passed through the cell is equal to Q. That is, in mathematical format, we can write M is directly proportional to Q. We know that Q is equal to I into T. Substituting this value in the above equation, we get M is directly proportional to I into T. Now we have to remove this proportionality by introducing proportionality constant Z. So M equal to Z into I into T, where Z is the electrochemical equivalent of the substance liberated or deposited at an electrode. When I is equal to 1 ampere and T is equal to 1 second, then Q is equal to 1 coulomb. At this condition, M is equal to electrochemical equivalent of the substance. Thus, the electrochemical equivalent is defined as the amount of the substance liberated or deposited at the electrode by charge of 1 coulomb. We can calculate electrochemical equivalent of the substance produced at the electrode is equal to molecular mass of the substance divided by number of electrons involved in that reaction into 96,500 coulomb. By using these Z, I and T, we can calculate the amount of the substance liberated at anode or deposited at the cathode. Thank you.